Hello everyone, welcome you to today's session on operating mechanism and testing of circuit breakers. So the first topic is operating mechanism. So we know that when we have a circuit breaker and the circuit breaker is going to operate on a fault, the contacts has to get separated. That means the moving contact has to move away from the fixed contact, is it not? So when this moving contact has to get separated from the fixed contact, there should be some mechanism which is trying to pull the moving contact. So that pulling of the moving contact can be either due to spring, solenoid or compressed air. That means the circuit breaker contacts can be closed or opened using any of these, that is spring, solenoid and compressed air. So whichever mechanism is being used, the operation, both closing as well as opening, should be quick and it should be reliable. So when you compare to opening and closing, closing is always slow compared to opening. And keep in mind this closing can be done manually also. So for reliability, both closing as well as opening of the contacts of the circuit breaker, it should be independent of the main supply. And usually for opening, we go for spring. Okay, for opening we go either for spring or for compressed air, that is to open the contacts of the circuit breaker. Whereas for closing, you go for the spring, you can go for the solenoid, or you can go for compressed air. So opening and closing both can be achieved by spring and compressed air, but solenoid mainly used for closing operation. And when we use this spring, especially for both opening as well as closing, we need to have two separate springs. Okay, we need to have two separate springs, one which is used for closing and one which is used for opening. And always the closing spring will have a higher energy level compared to opening. Clear? The closing spring should have a higher energy level compared to the opening, and it will be usually operated by motor driven gears. So for when you have a oil circuit breaker, solenoid is used, okay, for closing, and spring is used for opening. Whereas for a medium sized circuit breakers, where provision of battery for a solenoid is not possible, a spring is employed for both closing as well as opening. And in extra high voltage oil circuit breaker, compressed air will be used for closing and the spring will be used for opening. So the spring has to be charged, okay, before either opening or closing, the spring has to be pre-charged. So whereas in the case of air blast circuit breakers, we use compressed air for both opening as well as closing. And in the case of SF6 circuit breaker, compressed air is used for closing and spring is used for opening, or you can use compressed air for both closing as well as opening. In the case of vacuum circuit breaker, we have a solenoid or a spring mechanism which is fixed to the lower end of the metallic bellows, or it will be placed inside the chamber during closing or the opening contacts, and the closing mechanism will be trip free. So when we compare these three, that is spring, solenoid and compressed air, springs are actually very good for opening, and closing it is not preferable usually. Why? Because the closing spring should be operated usually by a motor. So that is why springs are usually very good for opening, because their force is very large. And for closing purpose, solenoids are very good. That is because the force of attraction of the solenoid will increase when the distance between the contact will reduce. So why they are not used for opening? Why solenoids are not used for opening? That is because they are very slow in their action. Whereas what about compressed air? Compressed air you can use both for closing as well as opening, because its pressure, it remains constant. So it remains almost constant. So this is the characteristics for the operating mechanism during closing and opening. So you can see that for closing operation, the compressed air has a constant force, whereas as the distance that is from opening to closed position, when we go, the spring force is being decreased, whereas the solenoid force is being increased. The same way for opening. See, for opening either you go for spring or compressed air, not go for a solenoid. Okay, so this is all about the operating mechanism. Next we will see how the circuit breakers are being tested. So the testing of circuit breakers is mainly carried out in two ways. So first one is called as the routine test, and the other one is called as the type test. So what is meant by this routine test? Routine test means it is carried out on every piece of circuit breaker. Say you have a lot of say 20 to 25 circuit breakers. So all those 20 to 25 circuit breakers will be tested. Okay. So why it is done? The routine test is mainly done to confirm the proper functioning of the circuit breaker. That is why it is performed on each and every piece of circuit breaker. Whereas a type test is performed especially in high voltage laboratory, where say you have a 20 or 25 circuit breakers, out of that only 1 or 2 sample piece will be tested. Okay, this type of test is done, the type test is done mainly to test the mainly to confirm the characteristics and the rated capacities as per the design. So these are the main two testings which are being done on the circuit breaker. It's a broad classification. Okay, and all the routine test and the type test will be performed according to the Indian standard codes, that is IS codes, or International Electromechanical Commission, that is IEC, or British standard codes, that is BS codes. So now what we will look here is, we will be looking into how the circuit breaker is tested for breaking capacity, making capacity, short time current, rating capacity. Okay, for when we come to the testing category, we have direct testing techniques, we have indirect testing techniques. We will see in the coming slides. So first we will move on to short circuit testing stations. Okay, mainly there are two types of short circuit testing stations. One is in the field, that is under the existing real situations, okay, present situation, and the other one is the laboratory type, where you have a setup. So short circuit testing will be performed either on field or on the laboratory type testing station. So we will see what is field type testing station and a laboratory type testing station in detail. So in a field type testing station, the power required for testing is derived from a large power system. That is because we know it is in the field, under the actual your substations where you have, there you are going to conduct this. So in the field type testing station, the power required for testing of the circuit breaker will be derived from a large system. The circuit breaker will be connected to the power system, and large amount of power is easily available. So this method of testing is economical for testing of very high voltage circuit breaker. But even though it gets a large power for testing and it can be easily conducted without any setup, it has some drawbacks. So what are the drawbacks? Say you are going to test the circuit breaker for research purpose. So research purpose means, okay, one trial you didn't get, you go for another trial. If you keep on repeating this would be a problem for the actual electric supply, right? So because you are interrupting in the actual existing, so say you take an example of a substation where you are going to test the circuit breaker. If you keep on testing the circuit breaker, what is going to happen? The power is going to get interrupted. That is why the field type testing station, you can test one or two circuit breakers, but you cannot frequently keep on testing the circuit breakers. That is one thing, disadvantage. And say if the load is getting varied and the existing in the real time, if the load is getting varied, then the power which is available for testing the circuit breaker will be entirely varying. That also will be a problem. And you cannot control the transient voltage or the recovery voltage. That is the drawback of this particular field type testing station. Whereas in the laboratory type testing station, you will have a setup. It is that setup, equipment will be meant especially only to test a circuit breaker. So what you can do, you can keep on testing the circuit breaker n number of times, okay, or you can test different circuit breakers. You can take a whole day to test the circuit breakers, no problem. But what will be the disadvantage? Disadvantage is initial setup cost is there, no? That will be very high, and you will not have a large power to test a circuit breaker. You will have a limited power to test the circuit breakers. So but what will be the advantage? Advantage, one thing I have already told you, you can test n number of times, okay, and you can have a control over your restriking voltage, recovery voltage, current, everything. And you can carry out the testing of circuit breakers of any large capacity. So these are the disadvantages of field type and laboratory type testing station. So next we will see a setup wherein you are going to test the circuit breaker. This is a laboratory kind setup to test a circuit breaker. So if you look here, you have a short circuit generator. Can you observe? This is a short circuit generator which is used to provide the power for testing. This is the laboratory setup, okay. So coming to this, you can even see the master circuit breaker, you can see the mix switch, you can see the short circuit transformer. These are the test circuit breakers, test cells 1, 2, 3, 4. And you have a motor, you have an impulse excitator. Now we will see each of these components one by one. First is the short circuit generator. It actually provides the power for testing. And the design of this type of short circuit generator is different from your normal generator. Okay, so these generators will be designed to have a very low reactance, so that it gives the maximum short circuit output. And they are provided with a flywheel, so to supply the kinetic energy during short circuits. And you can see here this generator is being driven by a 3-phase induction motor. So, so what will happen when this particular short circuit generator, the short circuit current will have a demagnetizing effect on the field of the generator. So what will happen due to this? Due to this, the field current will be low. So the generator EMF will also be low. So to counteract or on the demagnetization effect, we go for impulse excitation. So you can observe an impulse excitation here. That is in order to overcome the demagnetizing effect. So at the time of short circuit, what will be the field current? The field current will be almost 8 to 10 times the normal level. Next, coming to the short circuit transformer. So what is the short circuit transformer? So the short circuit transformer again has a low reactance. Okay, and this particular transformer is designed in such a way that it can withstand repeated short circuits. Okay, so, so to get the different voltages for the test, its windings are arranged in sections. So you can have either a series and parallel combination of these sections to get the desired test voltage. So to get a lower, why the transformer is required? Transformer usually steps up or steps down, right? So to get a lower voltage than the generated voltage, to apply it for the testing circuit breaker, you are going to have a short circuit transformer. Next, how should this work? When there is a short circuit current flowing, the circuit breakers under test here, no, this has to trip. If this doesn't trip, what will happen? This entire setup will get damaged. So in order to protect this entire setup, you have a master circuit breaker. So the master circuit breaker is a backup right here. It is a backup circuit breaker. So if this circuit breaker under the test, no, it fails to operate, then your master circuit breaker has to operate. So after every test, the circuit breaker under test you have to check. So next is the make switch or the making switch. So what is the making switch? If you close this, the current flows through the short circuit transformer through the to the circuit breaker under the test. Next come to the reactors and resistors. So these resistors and reactors are connected over here to control the short circuit test current. Okay, to control the short circuit test current. And one more thing is they will also control the power factor and as well as the transient recovery voltage. Transient recovery voltage. So this is the laboratory setup of your circuit breaker testing. So what is the testing procedure? So how exactly you are going to test this? So first the motor is being driven. The motor drives the short circuit generator to a certain speed. It's okay. So the motor will drive the generator and it will make the generator to rotate at a certain speed. After that, this motor will be switched off. Clear? That is the first step. Yes, just have a look here. So first, what should happen? We have a motor. That particular motor has to drive the generator, and once it has attained a certain speed, you switch off the motor. Second step is you have to switch on the impulse exciter. Okay. Next, what has to be done? This master circuit breaker contact, see to that it is in the closed position. Then in case you have any observing system, no, that metering system, that you have to switch on. After that, you are going to apply the short circuit current to which one? To the test under this, the circuit breaker which is under test. So what you have to do, you have to close the make switch. So make switch is closed. Now the circuit breaker under the test, once the fault current flows, what should happen? The circuit breaker which is under test, you know, they have to open its contacts. So once in case it fails to open the contacts, then which one has to open the contact? Master circuit breaker has to open the contacts. And after that, once it is opened, what will happen? The impulse exciter which was applied, now it has to be turned off. So this is the procedure. So the testing procedure is given here. This is how the laboratory type testing is being done. It has steps one by one. The same way it has to be carried. So usually this testing is not possible to perform manually. So you have an automatic control for this purpose. Usually the time of operation of this particular testing is 0.2 seconds. So next, as I've told you, we will see what is meant by direct testing and indirect testing of the circuit breakers. So direct testing. So direct testing means the circuit breaker is tested under the condition which actually exists on the power system. So what will happen, you see here, you have the generator which is driven by the motor, the reactance, you have master circuit breaker, you have making switch, you have a transformer, you have the circuit breaker under the test. And what is being done here? Your circuit breaker under the test is subjected to the restriking voltage. It is subjected to the restriking voltage which will actually exist practically. Okay, if you have a circuit breaker in a power system, how the circuit breaker will work? It will be subjected to a high restriking voltage, is it not? The same large restriking voltage is being made to be appear across the circuit breaker under test. And you can see the reactor. This reactor X is to control the short circuit current, as I've already told you. You have the capacitor C, R1 and R2. It is used to adjust the transient restriking voltage to which this voltage you are applying across the circuit breaker. So usually the short circuit test which you carry out is breaking capacity, test for making capacity, duty cycle test and short time current test. So we will see one by one. So this testing for breaking capacity. So first of all, what will be done is you will see to that the circuit breaker under test as well as the master circuit breaker contacts, they are both closed. And what you do, the same testing procedure you have to follow. You have to close the make switch and the short circuit current is made to flow through the circuit breaker under test. So what has to be taken care of? You have to take care of the symmetrical breaking current, asymmetrical breaking current. You have to take care of the recovery voltage, need to take care of the frequency of oscillation and the rate of rise of restriking voltage. And the circuit breaker, it should be capable of breaking all currents up to its rated capacity. Usually you will test for 10%, 30%, 60% and 100% of the rated breaking current. Next is a test for making capacity. Making capacity means the master circuit breaker and the circuit breaker under test will be closed first. After that, short circuit current is made to flow. So what is the first value of the what is the peak value of the short circuit current? Peak value of the short circuit current, that will be noted. Next, coming to the duty cycle test. Duty cycle test will be performed like breaking, after 3 seconds again breaking, after 3 seconds again breaking. It will be conducted for 10%, 30% and 60% of the rated symmetrical breaking capacity. And it will be, the second test will be break, after 3 seconds again make, again break. So this should be performed on not less than 100% of the rated symmetrical breaking capacity and not less than 100% of the rated making capacity. So that you have seen the ratings of the circuit breaker, is it not? During that time I have told you duty cycle rating. So the same thing, whether after 3 seconds it is going to break or make, that is going to be tested for 10%, 30%, 60%, 100% of the capacity. That's all. And next is the short time current test. The last one is a short time current test. Short time current test is nothing but the short circuit current is made to pass through the circuit breaker under the test for a specified duration, say 1 second or 3 seconds, and the current which is flowing, that the short circuit current which is flowing for that 1 second or 3 seconds, it is measured by using an oscillograph, and the short circuit current, whatever is flowing through the circuit breaker, it should not damage the circuit breaker, because fault current is flowing, is it not? The circuit breaker contacts are not open. So what you have to do, you have to see to that the circuit breaker doesn't get damaged, and the current wave is being observed, and then the equivalent RMS value of the current is being calculated using I equal to root of 1 by 3 I naught square plus 4 times I1 square plus I3 square I5 square plus I7 square plus I9 square plus 2 into all the even intervals, I2 plus I4 square plus I6 square plus I8 square plus I10 square. That means the current wave whatever you have got, it is divided into 10 intervals, and those 10 intervals current is being calculated this way, and you get the RMS value of the short circuit current. So when we have a high voltage circuit breaker of large capacity to get tested, it is not possible in a laboratory setup to test with a very large power. In such case, we go for indirect testing of the circuit breakers. So the indirect testing of the circuit breakers are mainly of two types. Okay, first one is unit testing, and the second one is synthetic testing, unit testing and synthetic testing. Unit testing is each unit, let us say you have a high voltage circuit breaker, it will be having several arc interrupter units. So each unit has to be tested separately. Say suppose if you test one particular unit, that means you say that the entire circuit breaker is proper. That is unit testing. Synthetic testing, what you do is you will have two separate sources. Instead of you having one source, you will have two sources of power supply. One is an voltage source and the other one is the current source. So the current source will be a high current low voltage source. So what is the function of the current source? It will supply the short circuit current. Whereas the voltage source is a high voltage low current source. It provides the restriking and the recovery voltage. So you have two methods of synthetic testing. One is parallel testing and the other one is series testing. Series and other one is parallel testing. So out of this series and parallel testing, the parallel current injection method is widely used, so because it is capable of providing the restriking voltage and the recovery voltage as required by the different standards. So if you look here, this setup is a parallel current injection type or synthetic testing of the circuit breaker setup. So it will supply the current. So you can see that the high current source is nothing but a motor driven generator, and it will supply a short circuit current I1 into the circuit breaker which is under test. Got it? This is circuit breaker under test. So the generator will supply the current which is I1 to the circuit breaker under test. So this current I1 is a very high current. Next, you have the inductance L1. It is to control the short circuit current. You have master circuit breaker and you have circuit breaker under test. You have the make switch, and you have this triggered spark gap. Okay, so you have L2, you have C2. It will control the transient recovery voltage and RRRV. Can you see here you have a capacitor C1 and it is written root 2 Vs across it. So this capacitor C1 acts as a high voltage source. It will provide the recovery voltage. So this will provide, this is your voltage source, and this will give you the current. So both high current and high voltage is being applied to the circuit breaker under test. This will control your recovery voltage. So this will provide recovery voltage. Controlling of that will be done by this L2 and C2. And in order to apply it, you have a triggered spark gap. Okay, so by applying this high voltage and high current, you see how the circuit breaker under test is going to perform. If the circuit breaker under test fails to operate, then the master circuit breaker has to operate. So this is overall the testing of circuit breakers. So main test is routine test and type test. It can be either carried out directly or indirectly. It can be carried out in the existing, that is the field is real-time situation, or you can install a laboratory setup so that you can try to get the practical voltage, whatever is possible. So this is all about the operating mechanism and the testing of circuit breakers. Thank you.